Hi, this is Venkatesh. Welcome to Venki's Emerging Edge YouTube channel. So today we are mainly focused about ensembling technique. It is one of the main powerful technique in a machine learning. Why? How? It is one of the main questionnaire in a student. That means ensembling. What is meaning of ensembling? Is it ensembling and hybrid both are same? No, it is completely different. Because of the hybrid means we are combining more than one models. Our models may be same or different. But here ensembling means we are combining of different types of base models. Base models. Is it clear? Combining of different types of base models. So what is meaning of base models? It may be a weak learner model. Weak learner models. Is it clear? So what is meaning of weak learner? Again one more question. The weak learner means which model given a less accuracy. So generally, this is a one model, this model given a 98% accuracy. Another model is maybe given a 60% accuracy. Another model given maybe a 100% accuracy. These are all our models, but it is a weak model because of this is a less accuracy. That is one point. Next, this is also the overfit. That means we get maybe in machine learning we are mainly focused about 96, 97, 98, but here 100%. It is maybe a we are not considered. So that's why this is maybe a underfit, this is maybe a overfit. So these type of models we are combining all the models, then we are that is called ensembling technique. So that's why this is one of the powerful technique in a machine learning. So here, sir, why we are using of ensemble technique and how. In this video we are covered why and how. These two important keywords are covered in these videos. Okay? Clear. First of all, so why we are applying an ensemble technique means the first one is if any model is given a maybe a less accuracy, maybe a over accuracy. So less accuracy, that is called a underfit. Is it clear? What do you mean underfit? If any model given a less accuracy, maybe 40, 50, that is called underfit. Another one is a, if any model given a high accuracy, maybe 100, sometimes maybe a 101 like that, also 99 point like that. That means that is called a overfit. Is it clear? That models may be underfit and overfit. Why these are two different problems will be occurred. But which one is best? So that is called best fit means maybe a 96, 95, 96, 97. But why we are occurring a 100 fit means this is the main reason is bias. The main reason is bias. Why the overfit is occurred? The main reason is variance. Is it clear? These are main keywords in a play the entire machine learning technique. So that's why we will try to reduce the bias. We will try to reduce the bias. We will try to reduce the over variance. Then our model is a good fit. That is called best fit. Is it clear? Best fit. What is mean best fit? Our models may be less bias, less variance, and go for a best fit. But some models may be a underfit. Some models may be a overfit. So that's why we are combining of. So these are overfit and underfit models, and automatically we get a best fit. Is it clear? So that's why we are using of ensembling. Clear. So that means bias and variance. There's one more. The automatically we are controlling the accuracy, controlling the efficiency of performance. So that's why that is called a generalization. So generalization. Is it clear? So that means we are less. We control the maintain the less bias, maintain the less variance, we are maintain the generalization. For that purpose, we are using of ensembling technique. How it is possible? Yes, this is possible based on a three different types of ensembling techniques or ensembling algorithms. What are the three different types of ensembling techniques or algorithms? The first one is a bagging. What is the first one is a bagging. The second one is a boosting. The third one is a stacking. These are three different types of main techniques of ensembling technique. So sir, why we are in the bag? How the bagging will be applied? How the boosting will be applied? How the stacking? So which one is control the overfit? Which one is control the bias? Which one is control the generalization? That means bagging. So B means bootstrapping. AGGIN means aggregation. This is a full form of bagging. So this is main theme is control the variance. We will reduce the variance. That is the main theme of bagging. The second one is boosting. The boosting again, these are mainly three different types techniques. That is maybe ADA boosting, next one gradient boosting, one more XZ boosting. This main purpose of boosting means reduce the bias. That means control the underfit. The next one is stacking. Stacking is mainly used for here we have developed a new model that is meaning of a meta model. So that's why we control the generalization. So what is so can you say the any real time example? Yes, so I can say that. Bagging can take real time example. We are taking the 100 people opinions. Maybe some people may be given a lesser opinions. Maybe sorry, some people's may be a bad opinion. It may not be correct. But here we take the 100 people opinions. That means we are aggregating those all the opinions. Next one is a boosting. How the boosting will be applied? Here boosting means where we are in case of we are applying our different models, we can identify the weak learners. Identify the weak learners. For example, now okay. For example, if any movie, what is the movie? So final is maybe a hit or average. Hit or average. This is the final prediction. So here we are taking the 100 people opinion in which is maybe a 70 people are taking the hit, remaining 30 people are taking the average. But finally we are taking the all the opinions. So combine the opinion, we are taking the majority of opinion. That is called a bagging. Clear? Okay. Next one is a so boosting. Boosting means, for example, I may you are taking same example, taking the 100 people opinions. But in which it may be a 70 percentage of people is given a correct opinion, but 30 percentage of people may not be given a random opinion. That is maybe weak learners. So that's why we are next model we are go for a we are mainly concentrate on only 30% opinion is correct or not. So that means each and every time we are mainly focused about weak learners. So automatically finally get a correct prediction either maybe yes or no. Correct prediction. That is means a boosting. Boosting means the name itself. Boosting is a boost. The boost is given for only for weak learners. That only for weak bodies. Like that here boosting also applied for only for a weak learners. We can identify the each and every model. That means we ensemble we are combining more than one model in which one model given a weak learner we can identify that weak learner is given to the next model. The next model we can again apply the weak learners that can be given to the next model. Finally, all the models are iterated. Finally, find out the correct prediction. Next one stacking. The stacking means the best example of stacking is maybe A, B, C are three different types of doctors. It's given three different types of doctors' opinion. Again, these all the opinions are given by the one more expert doctor. So these are the base models. These are called a meta model. So this is example of stacking. By using stacking, we control the generalization. So this is a main introduction about ensembling technique. The next video we are discussing what is bagging, boosting, and stacking. So thank you.